Hey everybody, it's Mr. Wolf. We're back with one of the last couple of videos for Unit 6. These last couple of videos are pretty short. You'll just be learning some basic facts and definitions. Nothing too extensive, but very important nonetheless. Remember guys, your test is coming up very soon, so you'll have this video and a note sheet with it. One more video, another note sheet, and then we can start our test review. Remember that test is on the 23rd. That's a Tuesday, and we'll have both groups of Monday, Tuesday, Thursday, Friday students together for that. So you'll all be there unless you're fully virtual. So let's just go ahead and jump in to the content. Today, we're going to introduce a couple terms here of inscribed and circumscribed. We did talk about inscribed angles at one point, so inscribed may come a little bit more quickly to you than circumscribed. Let's go ahead and talk about it. So inscribed is what you would call when you fit one object tightly inside another. So that would be an inscribed object. So let's think we had a circle and a triangle tightly fit inside of it, then that triangle is inscribed within the circle. That's not too bad to think about. Now let's think about circumscribed. Circumscribed is very similar, but a little bit different. It is when you fit one object tightly around another. So kind of the same thing, but not exactly. So inscribed is when you fit one object tightly inside another object. Circumscribed is when you fit one object tightly around another. Inside or around. Those are the big differences. So with this picture, we'll redraw it to think about it. If we had a triangle with a circle drawn around it, we would say that circle is circumscribing or circumscribed to the triangle. So the one on the outside, circumscribed. The one on the inside is inscribed. Now let's end the page here and think of some examples of this. So what if a circle is inscribed in a polygon? That would be, and let's use these shapes. Say we have a polygon like this. Circle inscribed in that would look something like that. That's not the best circle in the world. Let's drag a circle in here. Maybe move this over. Well, that's almost it. So something like that. Perfect. Well, not quite perfect because it's not touching on that one side. But let's pretend it's touching. Oh, there we go. There we go. That is a circle inscribed in a polygon. What about a triangle inscribed in a circle? So if we had a circle like this, we'd have a triangle like this. And there's a list of facts you want to know about these kinds of things. And instead of giving extensive examples on each, we'll just list these facts out. And these are something you definitely would want to remember. So, first we'll say a circle. Second here. A circle is inscribed in a polygon if it is tangent to each side of that polygon. So let's think about what tangent means. We said we had tangent lines, and tangent lines were a line that just touched one point on that circle. So if we go back up here and look, Yeah, each side of that polygon, that square, is touching just at one point on the circle. What about a polygon inscribed in a circle? A polygon is inscribed in a circle if each vertex of the polygon touches that figure. Meaning every angle has to be touching the circle or whatever it is that it's inscribed in at least one point. So if we have a circle here and we inscribed a rectangle in it, each point on that rectangle would have to be touching the circle. If it wasn't, it would not be inscribed. One last example here. Triangle and is inscribed in another figure, probably a circle in our case, if each vertex touches that figure. So the same thing that we just did above. If you have some sort of circle that's pretty rough, the triangle, every angle is going to touch somewhere on that circle. So let's talk about inscribed circles. So an inscribed circle would be something like this. Let's say we have a triangle and a circle. That's close. Let's make this a little bigger. There we go. Something like that. So that circle is inscribed by the triangle. And here's some information on that. And inscribed, if I can spell that right. Circle will only touch the triangle at 3 points. Let's look. We got one here, one here, one here. So we're good. Okay, check there. Each of these 3 points is equal distance from the center point. So each point there would be of equal distance from this center point. If you guys remember our vocabulary, the lines here that show that equal distance from the center point out to the edges of that circle would be a radius. End the page a little bit here. So this point, this center point of the circle, when it is inscribed in a triangle, is called the incenter. The incenter of the triangle. We'll write that out as a definition. So the center point of a circle inscribed by a triangle is called the incenter. So that center point of the circle that's inside the triangle is called the incenter. Now there's another cool way of finding this that you'll have with triangles, and that is to get the angle bisectors of the triangle. So angle bisectors are those lines that separate the angles into two equal portions on a triangle or of any angle. So we bisect these angles And you'll notice, this is a very crude drawing, but you'll notice that if we bisect these angles, the point they intersect at is going to be that point. So let's write that down. The angle bisectors of a triangle intersect at the incenter. One very, very important fact here about the incenter is that it will always be within the triangle. Always within triangle. Think of it incenter. In is very much in the name there. Incenter, inside the triangle. So your incenter is always going to fall within inside of your triangle. Now let's reverse things just a bit here and talk about the inscribed triangle. So we're looking at a circle with a triangle inside it. Oops. Something like this. A little bigger. There we go. As you can see, we talked about this earlier. Each vertex is going to meet at only one point on that circle. Let's label our center point too, because that comes very important. That is the center point of the circle. And the center point of the circle is equal distance from the vertices of the triangle. So this distance from this point all the way up here, all the way down here, all the way down here, those three distances are equal. If you think about it, this also comes back to our radius because these vertices lie on the circle, and any point from the center of the circle that extends out to a point on the circle is a radius. So basically we have three different radii here, or radii, that are of equal distance because the radius is the same no matter where you draw it on the circle. So this point, the center point, of a circle that circumscribes, goes around a triangle I can spell is called the circumcenter. So last time we said, well, if you have a circle in a triangle, the center point of that circle is going to be your incenter. Well, now if we have a triangle within a circle, the center point of that circle will be the circumcenter of that triangle. One important fact about this is that it does not have to be within the triangle. It does not have to fall within the triangle. So there can be cases where this doesn't always lie within the triangle. Another interesting thing here, one very important fact is, last time we said, well, you get the angle bisectors of the triangle, and that will give you the point that those intersect at will be your incenter. Well, in this case, if you get the perpendicular bisectors of the triangle, they will land on this circumcenter. So the line that perpendicularly bisects each side of the triangle will meet at this point. So let's write that down. The point at which a triangle's perpendicular bisectors meet is called the circumcenter. Let's review what we've looked at. We've said that inscribed means when you tightly fit an object, a figure, a shape inside of another. Circumscribed is similar in that it's you tightly fit an object, circle, shape, whatever it may be, around another object. We gave some examples of inscribed circles or inscribed triangles there, or you could say that that circle is circumscribed by the square, or that triangle is circumscribed by the circle. We said a circle inscribed in a polygon is inscribed in a polygon if it is tangent to each of the sides of that polygon. A polygon is inscribed in a circle if each vertex of the polygon touches the figure, and a triangle is inscribed in another figure if each vertex touches that figure. Then we talked about a circle inscribed in a triangle. We said an inscribed circle will only touch the triangle at 3 points. Each of those points is equal distance from the center point. The center point of the circle inscribed by a triangle is called the incenter, and you can find that incenter by taking the angle bisectors of the triangle. We also said that the incenter will always fall within the triangle. And then lastly, we said the center point of a circle is equal distance from its vertices of a triangle when we have a triangle inscribed in a circle. We said that the center point of a circle that circumscribes the triangle is called the circumcenter, and we said that that circumcenter doesn't always have to fall within the triangle. And we lastly said that the point at which the triangle's perpendicular bisectors meet is the circumcenter. So if you want to find the circumcenter, you can either take a triangle and circumscribe a circle around it, and then find the center point of that circle, or you can get the perpendicular bisectors of that triangle. I know we kind of rushed through that, so if there's any point you think you missed, anything like that you couldn't find in the guided notes, make sure to go back, rewatch. If you need help, reach out to me or Mr. Rose, and try your best to remember these terms because these are very important for the test. Thanks for watching, guys.